Okay, so we're back again. Yeah, good answers. To the question about the why I can't be used out of the for loop. Uh, so now, let's see. Right. Oh, DJ, I see now your question there about this last one through. You're talking. I think you're talking about this last time through. But note that the last time through, I is 4. I is 4, so values of 4 equals I plus values at 3. And then the next time, when we do this, next time we do this I plus plus up here, I becomes 5, which now makes this condition false. And so now we're out of the loop. We never access this with values of 5 equals 5 plus values of 4. That doesn't, we never get into that position. And the reason why I want to note that, because that's a very good question, because that is something that gets really messes with us programmers a lot, where we will get these errors because we try to access an array out of bounds, where we try to access an array with a value that we can't. Okay, and the reason why this is just so frustrating for us programmers when this happens is because when I ask that question about what if we did this, what if we did, put it over here, if we did something like values of I like this, right? This would give us a compiler error. And the reason why is because I only exists in the loop, as some of you have stated. Thank you so much for those of you who took the time to answer that question. The reason why this would give us a compiler error because the compiler knows I exist inside the loop, not outside the loop. Okay, so I can't do that. But the problem is that if I were to try to, let's say, if this were instead of 5, if this were 6, okay, so now it would go in there and it would try to do values at 5 equals 5 plus values at 4. This wouldn't give me a compiler error anymore. This would give me a runtime error because it would try to access the array at a value that's out of bounds, an array value that the index that does not exist for this array. The reason this wouldn't give me a compiler error is because as far as syntax goes, as far as code, there's nothing wrong with this line. Did I put an integer type as an array index? Yes. Does the array exist? Yes. That's all it knows. That's all the compiler knows. The compiler doesn't know at runtime what the value of I is going to be. It only knows that what you've done from a compiler standpoint makes sense. What you've done is okay from that perspective. It's like if you were speaking a language like English or Turkish and you made a grammatically correct sentence. Okay, nothing's wrong with that. Microsoft Word wouldn't put the little red squiggle under your thing, or the blue squiggle, or whatever color it is these days, right? There wouldn't be this indicate, like you see all these red squiggles here for these non-standard English words, right? If I were to make a sentence that was grammatically correct, that's fine. But if the problem is not the grammar's wrong, the problem is at the time that it runs, it hits a snag. It tries to access something that doesn't exist. Okay, and that's why this is a problem. So runtime errors. Remember, I told you, way back at the beginning of the semester, that compiler errors. We don't like errors. We never like errors, right? But compiler errors are easier to find because when the compiler runs, when the compiler tries to compile the code, it immediately shows where the error is. Runtime errors are less fun. Right? Runtime errors, runtime errors are even worse because So we kind of get an idea of where the error is, but sometimes we don't know necessarily why. We have to do more work to find out the why. Because, for example, like, let me just go ahead and put this back the way that it was. If I had a 6 here, that's really the source of my error, isn't it? The source of my error is that I'm letting I get too big. But when the runtime error happens, it's going to point to this line here. The runtime error will tell me this is the problem. This is where the error was encountered. But the source of that problem is here. Right? So what happens if inside of this loop, what happens if there was 100 lines of code between the start of this for loop and this line of code? I might not know that the error that I need to fix is actually way back up here. I have to do some investigating. Okay? And as I've said before plenty of times, even worse than these runtime errors are the logical errors, because logical errors, we really have to do a lot of work to try to figure out where those are. Okay. All right. Let me take a break to see. So somebody has some questions. Right. Yeah, it's a runtime error because it occurs while the program is running. Remember, compiler errors, the program won't even start. Like, you click compile and it says, this is grammatically incorrect, syntax is a problem, this isn't going to work. Runtime error, we compile, we start the program, but it ends unexpectedly. It ends before completion. Logical error is the hardest to diagnose, the hardest to have a problem. We compile it, we run it, it completes, but it gives us wrong outputs. It ends with some information that's not what we expected it to be. Okay. If we want to talk about value 5, we have to write right. So if we wanted to have something with an index 5, we need to have an array that is at least size 6. Right. So let's say, for example, like that, we want to have an index 6. We could make index 5. We could make this size 6. We can make this size 7. We can make this size 50. We can make this size 1,000. Right? As long as this number is bigger than anything we index it with, we're fine. Okay. Now, usually what happens though is, let me go back. Okay. Usually, when we create arrays in Java, we want it to be a specific size because it represents a specific amount of data. So, for example, if I were to create an array for the students in this class, I would create an array of size like 150. I think there's 150 of you guys registered in this class. I would not create an array of 1,000 students to hold data that's related to 150 students. Because why? Because all that extra space is wasted. It's not useful. Okay, so yeah, so as long as my index that I index it with, the value is between 0 and n minus 1, whatever n is, the size of the array, then I'm fine. Then I should not get a runtime error. Okay. All right. So some of the things that we can do by processing through arrays. We can initialize an array with input values by looping through the array and each time through asking the user for a new value. Okay. We can initialize an array with random values. You can use math.random. This should give us, hopefully you guys remember that this gives you some random value between 0 and 100, not including 100. Okay. We can print values in the array. We can add up all the values in an array. We can search the array to find out what the largest value is. So we initialize with the first value in the array. Then we start with the second. Right? The reason why we start with the second, we don't need to compare the first value to the first value. We already know the first value is equal to the first value. Okay? And then if whatever the value is at our index we're looking at is greater than whatever the max is, then we just make that the new max. And when we're done processing through the array, whatever the value in max is going to be the largest value from that array. We can do other things. We can randomly shuffle the array. So I won't go into details. I won't go into a lot of details about some of these next examples, but I would like you to take a look at them. Yeah, okay. I want to make sure I was recording before I moved on too much more. All right. But basically, the way this does is we just create a random index as we're processing through the array, and we just swap what's in index I with what's in at that random index that we created. Okay. Sometimes we are going to end up with swapping a number with itself. Like we'll end up swapping index 3 with index 3. You know, that may happen on occasion, but for the most part, this is a way to shuffle the values in an array. This is a useful algorithm. We might want to shift elements, acting like a queue, right? Where we might want to take what's in the first position, either move it out, either do something with it, or move it to the end, but every other thing in the array move it one position forward. And this would be something like this. Now, if we want to take that first element and put it at the end, we have to hold on to it. Okay. So what we do is take that first value, we store it in a temporary variable, then from then on, we just copy what's at position 1 into position 0, position 2 into position 1, position 3 into position this, and so forth, right? Over and over and over and over. And then at the very end here, if we want to take that first element and move it to the last position, we can do that like this. Okay. Because of the way arrays work, we can have a special for each loop. Now, this is useful. This is useful if we don't need to know what position in the array we are currently at. So in the for loops that we've looked at so far, let me actually just go back here. Here, we needed to know what was the thing in position, okay? What position we were at, right? We're at index 1. We're moving things from index 1 to index 0. We're at index 2. We're moving what's in index 2 into position 1, and so forth, okay? Here, if we don't need to know what position we're in, let's say all we're really trying to do is just print all the values in the array. We can do this using what's called a for each loop. And so what happens is each time through, this takes the next value in the array and puts it into this variable value. So what I'm going to show you here is the equivalent of what you already know this looks like. Okay, what this looks like. Good old Microsoft Office correcting my stuff. Okay. So this would look something like, so what I didn't realize it was going to go off the edge of the screen like that, so I'm going to go like, which side? So this operates similarly to this. There are some differences, and I'll explain what those are in just a moment. But basically, we start at the first position. As long as there are values remaining in the list, we take the value at the position we are at, and I guess actually, this should actually go over here too. I just realized. Okay. because we take the thing that's at position 0, at the first position in the array, right, and we put it into value, we process through, then we come back at the end. That's actually not, there's actually more differences than I thought. Because the problem is what happens if I is greater than, what happens if I is too long at this point, too many at this point? Okay. I tried to explain this in a way that made more sense, and I think I may have confused it more. Basically, what's happening is, I'm going to take this out of here because this could actually cause a runtime error the way that it's done here. So this and this operate the same way. The combination of these two things and this operate the same way. And that we start at the beginning of the list, we check, you know, as long as there's stuff remaining, we take the whatever thing we are in and we assign it to value, we process, and then we go to the next item. Okay. A key difference is, some key differences are that here, in this version here, there is no such thing as variable I, right? There's no variable I that we can use inside the loop because we didn't declare a variable I. Another one big key difference too, that could be a key difference here, is if this list is empty, if it's an array of size 0, which doesn't really make sense that we would have an array of size 0, but it is possible, then this loop won't execute at all, okay, because there won't be anything. It'd be like if this was 0, I is less than 0, which it's not, then it would just jump right out. Okay, so let me delete this out of here because you don't need this anymore. Okay, so this is a way that if we don't need to know what position we're in, so if all that we needed to do was display everything in the list, display everything in the array, we can do that. If all we needed to do was add up all the values in the array, we can do that. All right. So if we look back at the opening problem that we talked about, we want to read 100 numbers, we want to add up we want to get their average, and we want to find out how many numbers are above the average, we can do that. All right. So actually, let's do that as an example now. Let me stop sharing this, and let me share my JGrasp instead. Okay. I don't want to pull up this one because then you'll see the solution. I want us to work through this one together. So let's do, I don't remember how I named these before. I want to name them all similarly. Lecture. Okay. Just get into the habit of typing public, static, void, main, string, args. Okay. And let me go ahead and make this a little bit bigger so you can see it better. I know some of you are probably watching this on your phones, so I want to make sure you can see it as well as possible. Okay. One thing that this new topic that we are talking about now should have shown you is that now you know what these brackets mean. Okay? Now you guys know that what this represents is this is a string array. This is an array of strings that are being passed to the main method. So when you run this program, there is an array of strings that gets passed to the main method. Okay, and let me do this and save it. And you know, I can compile this and run this, right? Compile this and run it. Oh. Compile it and run it, and it doesn't do anything, right? There's no lines of code that does anything. But you know what I can do? I can display how many items are in this array, right? How would I do that? Let me ask you that as a question. Let me ask those of you who are paying attention. All right. If I were to say, one, how would I display how many items are in the array? Not what's in the array, but how many items. How many strings are in the array? And two, what would that display? So how do I display it? What do I display? Okay, Alpair. Yeah, array name. What's the name of the array? Okay. Yep. Hakan, you got it? Okay, so someone else, okay, what would display? So if I do that, so that's how I display it. I can compile it. It should compile just fine. And what is going to display? Yep, we would display an integer value, but what value will it display? Let me get a couple of other people to chime in, give some answers that you think. Number of you guys are thinking through. 4, 5, 2, 1, 0. Okay. Right. So good. By the way, while I'm thinking about it, Emre Gulbay and Alper Kaya, I noticed that both of you seem to have the same base profile picture. I'm assuming that must come from somewhere. I would love to know where that comes from. So if one of you guys wants to tell me that, I would be much appreciated. So, all right, so let's take a look. Let's see. I compiled it. All right, I compiled it, and I'm going to run it, and let's see what displays. 0. 0. So that means that this is an empty array. So if I were to say, okay, system dot out args at 0, I won't get a compiler error because there's nothing wrong with this as it is. Okay, but I will get a runtime error. Array index out of bounds. The thing is, for an empty array, I can't index it at all. Because remember, this array has nothing in it. This is an empty array. It has no values at all. So if I try to access the first element in an array that has nothing in it, that's already out of bounds. That's already a big problem. Okay. All right. So, all right. We will talk, not this week, but next, about what the string array that you're passing is. So, because some of you guys said, oh, it's our codes. Oh, it's something else. And I'm glad that you guys are thinking. You're like, what is that? I don't know what that is, you know? So I'm glad that you're thinking about it. We will talk about, and if you want to look ahead in the slides, you're welcome to do it. We will talk about what that is, what that string array is, okay? Doesn't have the default values there because 0 index represents the first item But if there is no item at all in the array, then there can't be a first item. Okay. All right. One of you asked, can I change the name of this? Absolutely. I could call this CSE if I want to. Now, I would need to then change this, because if I try to run this, if I try to compile this, it's going to give me a compiler error because this whole args thing doesn't exist, right? But if I call this CSE also, compiles, and it runs. Right? And the reason why is because, remember, the compiler doesn't care what I name this. It just knows that when I compile and when I run, it's looking for something that is a public method, that's a static method, that's a void method, it's called main, and it has a string array as a parameter that's being passed. What it's called, compiler doesn't care. Everything up to this point is the only thing that matters for running the code in this method. Okay? This, what it's called, doesn't matter. We call it args because that's the standard. That's just what we do, right? That's something we just know that all Java programs have that, and it's just for what's the word? Consistency. Okay. All right. So we talked about that some. Again, next week we will talk about what that args array is. Okay, why it's important. All right. So let's take a look at what we're supposed to be doing. All right. We want to read 100 numbers, compute their average, and find out how many numbers are above the average. Let's see. All right, so how do we read in 100 numbers? How do we read in one number? How do we read in any numbers? What's the first thing we need to do? All right, we got to use a scanner. Okay, good. All right. Okay, so now we have a scanner. Now what? Define. Yeah, we need to use a loop because we need to do this 100 times, right? We need to read in 100 numbers, but we need to hold on to those values, right? So we could just say double value, right? Or I is less than 100, I plus plus. Let me put my little curly braces on so we'll have it. Okay. But yes, right, Omer. We have to create an array because we're not just calculating what the average is. We need to also be able to find out how many numbers were above the average, right? So we need a double array of size 100. Okay. Now, one of the things that you're gonna see is what would make this easier for us in the long run. Because what if we wanted to change this from 100 to 50? You know what? Let me get to that after we do one other thing. All right. So we've read in all the values. We're reading in all the values. We also need a total, right? Because we need to be able to calculate the average. Right? Right, we could use, you're right, value dot length, so perfect. Okay. All right. So we've read in all the values. We also need a total, right? And the reason why is because we are going to add this, going to add value to it, because once we're done with the loop, we need to calculate what the average is. So we need to have this total divided by the 100 to make it the average. Right. We can initialize total to 0. We can add it inside the loop. Now what we could do is we could just do 3 separate loops. We could do for n I equals 0 up to length, next double, then loop through it, adding value to total. So let me show you how that would look. Get all the values, total up all the values. So average is equal to what? Total divided by, you might be tempted to say 100, and that would work if we're reading in 100 numbers, but as, who was it suggested? As Alper suggested, right? If we use this each time, then we only need to declare that one time. Okay? So if we do that, all right, okay. So now it's my average. Now I want to count how many numbers are above the average. So how can we do that? Now we know what the average is. Now we need to go back through the array again, right? Ah, good call. That was a typo on my part. That was a same thing here, by the way, in line 12. Good call. Thank you for calling attention to that, Omer. Okay. So now we have an array full of values. We have the average of it. We're going to have to go back through the array again, right? And as we get to a value, right, we want to count. We're not wanting to display the values that are above the average. We want to just count how many values are above the average. So we need some way to count them, right? So how should we do that? Right, good. So you're saying, let's see, right? Basically, you're saying copy this because we're going to reuse something similar here. So here, but now if my value at the position I'm looking at is greater than the average, then I want to add one to count. Okay, good. Except there's only one little problem. If I try to and then I want to see how many above the average. I think one of you got it there with this new variable, right? Because if I try to run this as is, if I try to compile it, it's going to tell me some problems here. Well, for one thing, oh, can't find scanner. Didn't import the scanner. Now it should give me a different problem. Right? Because it says, I can't find this count thing. What's this count thing? All right, so we need to have count here. You say count equals 0. What type of variable should count be? All right, it should be an integer because it's going to be a whole number, right? There won't be like 3.5 values above the average, right? So we initialize it to 0 because as of right now, we haven't counted any values that are above the average. Okay. But every time through, if we find one above the average, we add one to count. So it should work now. Shouldn't get any compiler errors now. Okay. And it would run. I do want to make a couple of notes of the way that we did this. One, notice that we could combine this loop and this loop into one loop. Right? We could just say, okay, every time through the loop, get a value and add it to the total. Okay, we could say get a value, add it to the total. Now, there's a reason though that we can't include this in this loop. Why do you think that is? Why can't we just say, if the value is above the average, just add one to count up here? Why can't we just put all the count up here and all that? Why doesn't that work? Exactly. We don't know what the average is until we've gotten all the values. Once we've gotten all the values from the user, then we can calculate the average. Then we can figure out how many are above it. Okay, so we can't do this. We can't do this until we know this. We can't know this until we get all of these. Okay, but we can get a value and add it to the array all at the same time. Okay, and add it to the total all at the same time. All right. So try to look for those ways where you can combine things, but be careful because sometimes we try to combine things into one loop when they actually need to be spanned across more than one. All right. So to show this as an example, instead of 100, we'll go through 10 numbers. We'll put in 10 numbers. All right. We'll run it. Okay, so now it's waiting for input. And you guys, first 10 numbers that show up in my feed, I'm going to put in. All right, 5 it is. Out there, you tried to put them all in it all at once. First 10 people. Okay, how about that? 19, 1, 5 again. Man, a lot of you want 5. Wow. 5. Let's see what we got. 37. I like it. I like it out there. You're right. You're right. That is what I said. 26, 20, 22, 22. Okay. Now, all we know is that 5 numbers are above the average, right? So what happened was these were our 10 numbers. Okay. 5, 19, 1, 5, 5, 5, 37, 26, 22, 22. I don't know any information besides that there were 5 numbers above the average. My assumption is that that would be what? 37, 26, 22, 22, and 19. So these 5s and this 1 brought the average down below 19. Right? I don't know what the average would be of this. Right? Oh, what's going on? Oman, can you not see the JGrasp right now? Thought I was sharing this. Is it not being shared? Okay. All right, so I think maybe a problem on your end, Omran. So I don't know what the average is here, right? But I do know that it's below 19, right? Because these 5 numbers, 37, 26, 22, 22, actually if we were to do that in a calculator, plus 19 plus 1 plus 5 plus 5 plus 5 plus 37 plus 26 plus 22 plus 22 equals, I got 147 divided by 10 is 14.7. And yes, 5 of these numbers, these 4 and this one, are above 14.7. Okay. All right. So that's how we could solve that problem. And if you look at the analyze numbers routine, you know, it's got a little bit more, like they got some prompt stuff. They also do how many. They ask the user for how many number they're going to give. And then we use this variable n as a way to declare how big the array should be. Okay. So similar to us, we just said, okay, we'll just say you're going to put in 10 numbers. Here they say, how many do you want to put in? Okay. So then notice here we go from 0 up to n minus 1, getting all the numbers, and we add them all up to the sum. They called it sum, we called it total. They calculated the average. They said, okay, now let's count how many are above average. And then they said, they actually tell us in this example what the average is, which we can do that, right? Because we can have that as a variable, and how many of the elements are above the average. Okay, so they did a little bit more than we did, but that's okay. We both had kind of a similar idea. Notice one difference, we used this in, and that was one of the things I was going to talk about, was that we can have this variable that represents the size of the array that then we use as a way to declare the array as well. So if the user puts in 100 here, it will create an array of 100 items. It will go and get 100 items. If they put in 10 here, it will create an array of 10 items. It will go through and get 10 items and average 10 items and find out how many above average the 10 are. Okay, so they used n, we used value.length. That shouldn't be a difference. I would suggest, as I believe it was Alper, was it Alper or Omer who talked about it, who said about using value.length. I can't remember. I would suggest using this more often, because this way you know for certain that you won't get above that. Like, you will not get an index out of bounds on the top end if you do it this way. Okay. N, its value, if we go back over to here, N, its value could change possibly. You might write some code not really thinking about it and change N without changing the size of the array. This way, if you always base your loop on the size of the array, you shouldn't get a runtime error like that as often. Okay? All right, so here we are, 11:04. What we'll do is we'll take another 10-minute break, and when you come back, we will talk about next week's exam, and I'll go through kind of what you can expect, or at least what I'm planning. I haven't written the exam yet because we are still kind of trying to figure this whole thing out, but it will be given next week during this class time. Okay? All right, so let's say 11:15, we will start that discussion, and I will see you guys then.